Hello friends, welcome to Top Scholars. Here we are again back with another topic, that is acid, bases and salts chapter. This is coming from chemistry part of your syllabus, and this chapter has details about acid, bases and salts as the name suggests. So in this session we will be dealing with different questions, and with the help of these questions we will try to explain majority of the concepts to you that are important from this chapter. So friends, let us go ahead and deal with the questions that are coming up. The question here is a MCQ question, that is multiple choice question. As you know, section A has many MCQs, hence we have added such questions for your practice. Looking at this question, you may pause the video and try to attempt the question and then recheck the answer with our explanation. So let's begin. Here it is written that which of the following salts does not contain water of crystallization. For attempting this question, you need to know what is water of crystallization. Basically, to give you an idea, whenever there is a chemical compound written and then it is followed by dot H2O, and whatever is the number for this, H2O is representing the water of crystallization. Okay. So we need to find out the chemical formula for these things, then we will obviously understand whether they are having the water of crystallization or not, right? What are the options given to us? Blue vitriol, baking soda, washing soda and gypsum. So these are the options provided to us. Let us have the solution for this question. The answer is baking soda, but let us not see over there. We will deal with the other options first. Here we have blue, you will have an idea that it has something to do with Cu. Okay. In our other sessions, we have talked about how CuSO4 is having bluish color or copper sulfate is having blue color. Okay. This take you have already been noticed from your chapters, revision or study as well. But here we are just talking about relating the concept so that it will be set in your mind and you will not forget it in your examination. So, blue vitriol is CuSO4 dot 5H2O. This 5H2O is nothing but the water of crystallization. That means this is not the correct answer. Let us go for another one. Here we have washing soda. It has Na2CO3 dot 10H2O. Okay. Again we have the water of crystallization. For the third one, it is gypsum. Gypsum is calcium sulfate along with the water of crystallization. So, CaSO4 dot 2H2O. Hence, this will also have water of crystallization. So, what is remaining? We have baking soda which is remaining. Baking soda is nothing but sodium bicarbonate. Whenever we write sodium bicarbonate in chemical form or in chemical equations, we don't have the water of crystallization with it. Okay, let us see over here. Sodium bicarbonate means NaHCO thrice, right? This chemical formula does not contain the water of crystallization. Hence, our correct answer is baking soda. Okay. So, friends, to deal with this question, okay, we have taken up this clue that 5H2O or something and H2O will be there in the chemical formula. But for your conceptual understanding, you should know what is the water of crystallization itself. The name is also suggesting you the meaning. Okay. Always try to find out the meanings of the terms that you are studying. Alright. The next question is, here again we have MCQ. It says, which of the following solutions in water does not conduct electricity? The options are HCl, NaCl, C6H12O6 and H2SO4. Again, you can name all of these things, right? Because in your chemical reaction chapter, we need to find out the chemical formula for the chemical names that are provided to you, right? So, this is hydrochloric acid if it is in liquid form, hydrochloride gas if it is in gas form. This is NaCl, that is your common salt, sodium chloride that we always eat, right? That is table salt. This one is glucose molecule. Please remember, C6H12O6 is glucose molecule. And next one is H2SO4. This is a chemical compound called as sulfuric acid. Okay, it is a very concentrated acid. So basically friends, we are asked about which of these solutions will not conduct electricity. For conducting electricity, we required free electrons or free ions. Let us see which of these can be converted into ions and which of this will not be converted into ions. Okay. As we said, this is a compound. It will give us H plus and Cl minus. Thus, ions are formed, electricity can be conducted. Then we have NaCl. This can also be formed into Na plus, and then we have Cl minus. Okay, again ion formation, again conduction of electricity. Then we have C6H12O6. This molecule over here cannot be decomposed by simply putting it in water and then stirring it. Okay, when you have some lemonade or some sharbats, then you might add sugar in it, right? It has sucrose. Sucrose is a disaccharide of glucose. But my point over here is that it will not break down simply by putting it into water or into the solution form. For breaking down of this glucose molecule, you need to undergo a whole lot of process of metabolism. Okay. So, this C6H12O6 cannot be ionized. Okay. We cannot have ion forms. Right. So, no formation of ions, no conduction of electricity, and hence we have our answer. Let us see over here as well. H2SO4 will obviously give you ions because SO4 minus is one ion and H plus is another ion. Okay. So, let us have the solution. It says that option C is correct as we have discussed. In aqueous medium, strong electrolytes dissociate to ions which conducts electricity. Whatever the options were given to you, HCl, H2SO4, these are all strong electrolytes, NaCl as well. Strong electrolytes meaning they will be completely ionized in their solution and their ions will be available for conduction of electricity. We also have weak electrolytes like acetic acid, which will give you the ions but it will not be completely dissociated. Alright. Since HCl, H2SO4 are strong acid and NaCl is a salt that is formed from strong acid and base, right? NaOH and HCl reacts to form this NaCl. It is a neutralization reaction. But my point over here is ions are being produced in all of these three cases. Hence, they dissociate completely and conducts electricity in aqueous form or in water. But this one, that is glucose molecule, is a covalent compound. Here we have ionic bonds present. Here there is covalent bond that is present. So, it does not dissociate and hence does not conduct electricity. Alright. So, the correct answer is glucose. The question here is, potassium carbonate is a basic salt. Give reason. First of all, you should know the term basic salt and acidic salt. Basic salt are made from bases, acidic salt are made from acids. Simple to understand, right? Let us see the answer for this. Why is potassium carbonate a basic salt? The solution here says that here we need to have the understanding of salt hydrolysis. Basically, we will be having salt and we will add water. Because of this, the hydrolysis will occur of that salt to produce the acid and base from which the salt is made. Alright. So, basically, when we will do the hydrolysis, the acid and base will be produced from which the salt is actually made. So, coming over here on hydrolysis, potassium carbonate will form strong base that is KOH and weak acid that is H2CO3. Okay, that means this KOH dissociates completely to give us OH minus ions. And since OH minus ions are released, it means it is showing us basic nature. Okay, so we can say that this potassium carbonate is a basic salt. In the question, we were supposed to find out the nature of this salt, right? Since we are finding KOH upon hydrolysis of this salt, hence we will say that the potassium carbonate is a basic salt. Questions coming from types of salt, that is salt families, is very important. You need to find out how is acidic salt formed, what do you mean by acidic salts, what is basic salts, and so on and so forth. Here is the question. It says that what will be the effect of the following substances on methyl orange and phenolphthalein? Okay. A case is of carbonate water and B case is of caustic soda in water. Now here this question is coming for 2 marks. Alright. Now this question is coming from indicator topic of this chapter. Methyl orange is an indicator and so is the phenolphthalein. They will have different color in acidic state and it will have different color in basic state. So if I have acid in a beaker and I have base in a beaker, when I will add phenolphthalein in both of the beakers, the color will be different. What will be the color? Let us see. So, first of all, in acidic medium, you should remember all of these things, right? In acidic medium, methyl orange is red in color and in basic medium, it is yellow. So, say for example, here I have acid and here I have base and I am adding methyl orange. Then, the methyl orange will be red in acidic medium and yellow in basic medium. That means I can extrapolate. If I have yellow color, it is basic solution, and if it is red color, then it is acidic solution, right? Now let us see the color changes for phenolphthalein. It is pinkish in basic solution and colorless in acidic solution. In your future studies, when you will undergo titration, you will see that how we can neutralize the acid that is present in our solution. Okay, you will have acid and then you will add the base from upwards and then the phenolphthalein will change the color. Okay, hence these indicators are very much important because we cannot identify acid and bases as it is, right? We have to see some visual changes that we can perceive. Okay, now coming back to the question, carbonated water is an acidic solution, hence methyl orange changes to red and phenolphthalein remains colorless. Because methyl orange is red in acidic medium, phenolphthalein is colorless in acidic medium, and this carbonate water is acidic solution. So obviously both the indicators will give the color respectively, which is there for acidic solution. Alright. Now going ahead, we have caustic soda. Caustic soda is a basic solution. Now just extrapolate it for the colors of the indicators. Yes, for methyl orange will be yellow, right? Methyl orange changes to yellow color and phenolphthalein will become pink in color. Alright. So, remembering the indicators, what are their colors in respective solutions, basic as well as acidic. And third point is knowing the chemical nature of these compounds, these substances that are given to you, whether it be carbonate water, caustic soda, baking soda and so on and so forth. Alright. Here is the question. The question says, which one of these is more acidic? Okay. Here we are provided with 1 molar HCl and 1 molar acetic acid. We have just talked about complete dissociation and partial dissociation, right? The question was about the electrical conduction, and over here we are asked about which one is more acidic. The solution or the compound which is giving us more acidic radicals will be more acidic, and the compound which is giving us less acidic radicals is less acidic. In other terms, the acidic compound which dissociates completely is prone to give us more ions, right? And the acidic compound which is not dissociating completely will be giving us less acidic character. Here, HCl is the strong acid and acetic acid is a weak acid. So, in this sentence itself, you can find out what is the correct answer for this question. Let us proceed. So, 1 molar HCl is a strong acid and hence dissociates completely to form large number of H plus ions. But 1 molar of acetic acid, that is CH3COOH, is a weak acid and can dissociate partially and thus produces less number of H plus ions compared to HCl. Alright. So, the correct answer is HCl, not acetic acid. Here, you should also correlate that more number of H plus ions will give us more acidic character in the solution. Hence, coming to the conclusion, 1 molar HCl is more acidic than 1 molar acetic acid. Here is the question. The question says, what will be your observation when an acid reacts with metal? Alright, how you can indicate that observation? So, here we are talking about the reaction wherein acid is reacting with metal. Okay, try to remember these general type of reactions, friends, in which you are being told that a salt and acid is reacted or an acid is reacting with metal. So, what is the product? General name would also help in your actual examination. Alright, here we are asked how you can indicate that observation. So, let us see. First of all, we need to talk about acid reacting with metal. This thing we have already talked in our sessions. in which hydrogen gas is being formed, okay, which can be checked by bringing a burning matchstick near the reaction medium and then the gas burns with a pop sound, okay. So basically hydrogen gas is being released, but we also are supposed to check or note down this observation. Then you will be bringing a burning matchstick towards the end of that test tube in which this reaction is going on, and then the gas will burn with a pop sound. You will hear a pop sound coming out of this reaction, okay. So that is the indicator of that hydrogen gas that is being released. So here let us take an example of this acid and metal. We have dealt with this reaction in our previous sessions as well. So zinc is the metal which is reacting with HCl, which is hydrochloric acid, and then we are having the formation of ZnCl2, that is chloride of zinc, zinc chloride, and then there is release of hydrogen gas. Alright. So we have given the reaction, we have given the balanced chemical equation, and we have given you a way to check the release of this hydrogen gas. Alright. Let us name these stuffs as well. This is zinc metal, this is acid which is HCl, and this is the hydrogen gas that is released. Here is the question. The question says, identify the compound of calcium used for disinfecting drinking water. Part B says, how is it prepared? And part C says, list two other uses of the compound. So first of all friends, why is there a need of disinfecting the drinking water? The water that we drink might not always be of utmost good quality. Hence, disinfectants are required so as we can use the water for our purposes like bathing or cleaning the utensils or washing the clothes, etc. Alright. Hence, when you will go for swimming pools or these kinds of similar places, you will see that there are disinfectants present in the water. So when you come back home, you will see your body color or your skin tone has been slightly changed because you might not be compatible with those disinfectants. Alright. So, long story short, there are always disinfectants present in water in such places. We are being asked what is the compound of calcium that is used, and then we need to show how it is prepared and then some other uses of that compound as well. So here is the solution for this question. The compound that we are asked is bleaching powder, alright, and the chemical formula for it is CaOCl2. Here we have calcium for Ca, O is written as oxy and then Cl2 is for chloride. So the chemical compound is CaOCl2 and the name of the chemical compound is calcium oxychloride. Alright. Now this is the bleaching powder, common name is bleaching powder, and how it is prepared, let us see. It is prepared by passing chlorine gas on dry slaked lime. What is dry slaked lime? We have learnt about slaked lime, right? It is calcium hydroxide. So we will have CaOH twice, it will react with chlorine gas and then we will have the formation of CaOCl2 along with hydrogen gas. So this is the reaction for formation of bleaching powder, that is calcium oxychloride. Now going ahead, let us name this. This is calcium hydroxide and this is calcium oxychloride. Now this is slaked lime, a common name, and this is bleaching powder, again a common name. You need to remember the common name of these stuffs because they are asked like that in your examination. Now we are also supposed to know the uses of this compound, right? One is for disinfecting the water. Another uses are, it is used as an oxidizing agent in many chemical industries. Since it is a chemical compound, obviously it will be used in chemical industries. The thing is, it is used as an oxidizing agent, okay, that you need to note down. Next one is, it is used for bleaching cotton and linen in the textile industries. So first we have used it in chemical, then we are given an example of using it in textile industries. It is also used in wood pulp bleaching and for bleaching washed clothes in the laundry, okay. So these are different uses of bleaching powder. This is the chemical name, chemical compound and the reaction for production of bleaching powder. The question here is, what is chlor-alkali process? What are the gases given off at the anode and the cathode respectively in the process? And then write the chemical equation which is involved. This question will fetch you 3 marks, okay. Over here, this term chlor-alkali process is suggesting you the products that are being produced, alright. Chlor is for chlorine gas and alkali is for a alkali that is produced. That is the hint for you to answer this question. You may pause the video and answer it, or else I am going to continue. Over here, when electricity is passed through an aqueous solution of sodium chloride is NaCl, it decomposes to form sodium hydroxide. Okay, NaOH is being formed, which is the alkali. But there is also release of chlorine gas, hence we have chloralkali as the name. Okay. So the process is called as chloralkali because of the products which are formed, chlor for chlorine and alkali for sodium hydroxide. As you know, NaOH is an alkali. It is a very strong base as well, right? Chlorine gas is given off at the anode and hydrogen gas is given at the cathode. Cathode is the electrode with negative charge, H plus is present, so it will be given off at that point. Chlorine gas is given off at the anode. Going ahead, chemical reaction is present over here. We have NaCl and then we have hydrolysis, that's why H2O. Electrolysis is going on, that means we will be passing current through this solution. So if we go for the setup, there will be electrodes present in the setup and then we will connect the circuit and electricity will pass through the solution. Alright. Then as a result, we are producing alkali and we are producing chlorine and hydrogen gas as well. Okay. So alkali is NaOH. Then finally, you also need to balance the chemical equation for which we have added these numbers. Okay. The question here is, write the chemical formula of plaster of Paris. Why should it not be left exposed to air? You have heard about plaster of Paris, right? It is also being used in construction process, so you might have also seen it. If you will leave the plaster of Paris as it is, then it will turn very hard, okay? It will turn very rigid. So, we should not left it exposed to air. But here the question is, why it should not be left? So, let us answer that. First of all, what is the chemical formula for plaster of Paris? It is calcium sulfate along with this water molecule. So, we will have CaSO4 got half H2O. Then, when we leave this POP in open, then it will absorb moisture from air and it hardens as we just discussed. Then it will change to gypsum, which is having the formula CaSO4 dot 2H2O. Right? So, to prevent this hardening, we should not leave it open. Okay? Here is the question. It says, what happens when baking soda is heating? Baking soda is heated and water is added to quicklime. Again, you should know what is the chemical formula for baking soda and what is the chemical formula for quicklime. Here, everything is coming from your acid and bases. Some of these things are bases, like baking soda is basic in nature. So, there are reactions which are being asked upon baking soda. Then we have this one. Here again, you have the reaction which is being asked. And as you can see, when you will know what will happen, then only you will be able to write the chemical equation, right? So, friends, this chapter of acid, bases and salts will lead you to gain marks when you know what are the products that are being produced. Alright, going ahead, let us see over here. First of all, we have sodium bicarbonate, that is baking soda. As in the question, you were asked about baking soda, right? Which is sodium bicarbonate. Just when you will know the chemical name, that is sodium bicarbonate, you can also have the chemical formula because sodium Na, bi is for H, so H and carbonate is CO3. So, we have got the chemical compound NaHCO3. Okay. This thing will decompose on heating to form sodium carbonate, carbon dioxide and water. The chemical reaction involved is, let us have a look on the chemical reaction now. So, this is the sodium bicarbonate as we talked, and what is it decomposing into? Na2CO3, that is sodium carbonate now. And along with it, we have carbon dioxide and water production. Alright, we will also be having the balancing, so it is done. Going ahead for the second part, that is quicklime is reacting with water. Okay, this will lead to the formation of slaked lime. This slaked lime is nothing but calcium hydroxide and quicklime is the calcium oxide, as you will see over here, CaO. CaO is reacting with water to form calcium hydroxide, which is having the common name of slaked lime. Understood? And along with this, heat is also liberated, which we have already asked you. We are repeating it because it might find its way to your examination. So, you need to be thorough with the concepts that are present in this session at least. Here we will also name it, this is quicklime and this is slaked lime. Here is the question. It says, give the nature and chemical name of the compound present in tooth enamel. As you already know, our teeth are very strong and they are strong because of a compound called as enamel. This is having a chemical name, that is calcium hydroxyapatite. Hence we say that calcium rich foods are good for your health. Okay. Now going ahead, we are asked about the nature and chemical name of the compound. We have already named the compound, it is calcium hydroxyapatite. Let us see what is the nature in the solution part. So the chemical name of the compound is calcium hydroxyapatite with the chemical formula Ca10PO4, which is 6 times and then we have OH twice. Okay. I know this is a very big chemical name for you to remember. Just remember this name and you will be finding your way for the chemical structure as well. Here we have calcium, so calcium is there. Hydroxyapatite. Just remember you need to add phosphate. Okay, so you can remember this P for phosphate and OH twice you need to remember like that only. Okay, so basically we have Ca10PO4 6 times and then OH twice. This is the crystalline form of calcium phosphate which is basic in nature, as we were also asked about the nature of the compound. Alright, so by writing this much thing you will gain your 1 mark very easily. Going ahead, here is the question. The question says, what are olfactory indicators? Now, we have been talking about phenolphthalein and methyl orange, right? We are saying that we need to perceive what are the changes that are happening. But what if someone is not able to perceive the visual change that is happening? Then they can use their olfactory, their nose, right? So we have something called as olfactory indicators, in which the smell of the compound will change when they are being introduced to acid or bases. Okay, so those are the olfactory indicators. Let us have a look over here. It says that some indicators showing a change in their odor in the presence of acids or bases are called as olfactory indicators, right? So as we talk, they are very useful for visually challenged students because such students cannot use other indicators. And to give you some example, clove, vanilla and onion, all of these things gives us olfactory indicators. Alright. The question here is, why do we feel pain when a bee stings? How do we get relief? Now remember students, these questions are coming from your events that are present in the chapter. Okay, like what is the pH in your stomach, that is HCl is creating an acidic environment, right? Then this bee sting will create some compound, rather an acidic compound, which will give you the pain. Okay, so you remember, so you can relate that these acid and bases are present in our day-to-day life. You just need to correlate it and then you can answer the questions very easily. Okay, so here it is said that how do we get relief? Now I want you to extrapolate your understanding before we go for solution. Basically I just told you that an acid is being released when the bee stings you. Then how will you cope up with that acid that is produced? Obviously we need to neutralize it, right? And for neutralization reaction we have base reacting with acid. So obviously for this acid we need to have some base that we are adding. Okay, and when we are doing that, acid will be neutralized and we will get relief. Okay, so this is how you may visualize what is happening in the question or what the question is asking you. Okay, let us go for the solution now. It says that we feel pain when a bee stings because bee injects formic acid, or another name is methanoic acid. Okay, in our body we can get relief by rubbing a mild base like baking soda. Okay, this is the soda that we can introduce to our site of injury and then we will get some relief. Alright. The question is, why does dry NH3, that is ammonia vapors, not changing the color of the dry litmus paper? Okay, so just the state is different, then why the litmus paper is not changing the color? Because if I have ammonia in liquid form, that litmus paper will surely change the color, right? That is the question which is being asked to you. And answering this question will fetch you 2 marks in our paper. So here we have dry NH3 which is not liberating any ions like OH minus, okay, as it is not in contact with water. Thereby, it has no action on litmus paper. Whenever we are talking about any acid or any base which is present in aqueous solution, we are getting the indicator's color change due to the ions H plus or OH minus that is being produced. This ammonia itself is not giving us the color, right? This ammonia, when introduced with water, will give us the liberation of OH minus ions from water. Okay, and we are detecting that OH minus ions which will give us the basic color. Okay, which will give us the color change for basic solution. Since we don't have ions in this form, hence we are not getting the color change in our litmus paper. Okay, ammonia solution in water turns red litmus blue as it forms ammonium ion and hydroxyl ion. Here, ammonia acts as a base by liberating OH minus ion as we just talked in our discussion. Thus, it will turn red litmus paper blue. Okay. Here is the question. The question says, give reason. During summer season, a milkman usually adds a very small amount of baking soda to the fresh milk. Or you are provided with an option, tap water conducts electricity but distilled water does not. So over here, this concept is relating to bio part a little bit. What happens is, in summer season, if you will leave the milk outside of the refrigerator for a long period of time, it will also decompose very easily as compared to the period in winter season. Okay. Why is all this happening? Milk is having microorganisms called as lactobacillus. These are bacteria. Now, since if the temperature is colder, their activity is slower. But since the temperature is warmer, their activity is increased. And hence, now they are able to grow and multiply and metabolize very fastly. Okay. But to slow down this activity of lactobacillus, a small amount of baking soda is added to fresh milk in summer season by the milkman. This is the usual case, alright. Coming back to the next part, tap water is conducting electricity. Just relate it with the ions. If the ions are produced, electricity will be conducted. If it is not produced, electricity will not be conducted. Okay. So, tap water is obviously having ions and distilled water is obviously not having the ions. Hence, this one is conducting and this one is not conducting. Okay. So, let us find out the solution to these questions over here. During summer months, the temperature remains high, owing to which lactobacillus increases in milk, resulting in formation of lactic acid, minimizing the basic pH of milk. As you know, milk is having a natural basic pH. It will lie down to the basic part of on your pH scale. But because of their activity of the lactobacillus, lactic acid is being produced, and if acids are produced, then the pH will range to the acidic part, right? Acidic side, that is 0 to 7. So, the formation of lactic acid will minimize the basic pH of milk. Hence, milkman will add baking soda to increase the overall pH, okay, of the milk, since baking soda is a base that helps to neutralize the milk in summers. So, since there is acid produced, we will add some more amount of base to maintain the basic pH of the milk. That is the whole purpose of doing this activity. Going ahead, also, if this lactic acid is being formed in larger quantities, then the fresh milk will get sour, okay. Basically, it will be spoiled and we will not be having that much taste coming from that milk. Hence, we are doing this thing. Going ahead, the next part is of tap water. So, tap water contains ions that conducts electricity. Distilled water does not contain ions, hence it doesn't conduct electricity. That is the answer for this question, okay. As ions are the carrier of current in liquids, hence we are having no ions, hence no carrier of electricity in distilled water. So friends, in this chapter, we have discussed many questions with you and we have discussed related topics with you as well. We have discussed what you should be knowing in this chapter. pH things are very important in different locations in your stomach, in environments, what is bee sting, what is it containing. So, many questions have come from this chapter in your previous years, hence you need to pay attention for this chapter very well. I hope this discussion has helped you for your preparation and thank you for your attention.